All right, so we're going to go over a few of the problems that we have here in this extra practice review. The first one is long division. So when you have long division, your numerator is going to go, it's your dividend, and it goes inside of the division bar. So 4x cubed plus 3x squared minus 2x minus 1. And you're going to divide by your denominator, which is your divisor. And so when you're doing this, you're always looking at the first term of your divisor and the first term of your dividend. And you're going to ask yourself, what do I need to multiply x by to get to 4x cubed? Or you can think of it as 4x cubed divided by x. Either way, your answer is going to be 4x squared. Okay? And so what you're going to do is you're going to multiply the entire group of x plus 5 by the 4x squared. So you're going to get 4x cubed plus 20x squared. And remember, in division, think of divide, multiply, subtract, and bring down. So what you're going to do is you're going to subtract that, and that's like adding the opposite. Your first ones are always going to cancel. You're going to be left with minus 17x squared. And now it's time to bring down, so minus 2x. And then you repeat the process again. You're going to look at the minus 17x squared and the x, and you're going to think about, okay, what do I need to multiply by to get from x to negative 17x squared? And it's going to be minus 17x. And now you'll multiply the entire x plus 5 by minus 17x. You should get minus 17x squared, and you'll get minus, 85x. Now you're subtracting that whole group, which is the same as adding the opposite, and the first term should cancel. If the first term doesn't cancel, you did something wrong. And now you're ready to bring down the last one, which is the minus 1. And so once again, you ask yourself, how do you get from x to 83x? Well, you multiply by 83. And then you multiply the entire thing by 83. So you're going to get 83x plus, that's going to be 15, carry the 1, 41. And you're going to subtract the entire group, which is adding the opposite, and you're going to get negative 416, which is your remainder. So your quotient is 4x squared minus 17x plus 83 plus negative 416 over the divisor x plus 5. The other way you could write this is you could do 4x squared minus 17x plus 83 minus 416 over x plus 5. Either one would be valid. The second one asks you to complete the square, put it in vertex form. We are going to expect you to complete the square. You cannot skip that step. And then from there, you're going to find the vertex, the axis of symmetry, the x and the y intercepts. So you know we're looking for the vertex form. We're looking for the actual vertex. We're looking for the axis of symmetry. We're looking for the x-intercepts. And we're looking for the y-intercepts. So first things first, we've got to get it in vertex form. So we're going to separate out that minus 2. We're going to move it over, and we're going to work just with this. With what's left in the group, we're going to take out the negative 1, because to complete the square, we have to have the a has to be 1, not negative 1. So we're going to factor out a negative 1. It's going to leave us with x squared minus 3x. Then what we're going to do is we're going to identify our new c value. Remember that c is always half of b. So our c value is going to be half of the negative 3. So it's going to be negative 3 over 2 squared. So it's going to be positive 9 over 4. So we're going to do plus 9 over 4. And then since I'm doing it on the same side, I should be subtracting 9 over 4. But in reality, what I'm really doing is I'm subtracting 9 over 4. Because it's minus 1 times 9 over 4 is negative 9 over 4. So this has to be a positive 9 over 4. My parentheses here will be x minus 3 half squared. And then minus 2, but that's the same as 8 over 4. So it's going to be plus 1/4. So now this is my vertex form. So let me kind of write this a little bit neater. It's going to be minus 1 times x minus 3/2 squared plus 1/4. This is vertex form. Then we're going to find the vertex from there. Well, you know the vertex is the opposite of what's in with the x. So it's going to be 3 over 2, and then it's going to be the k value outside, which is 1/4. So my vertex is positive 3/2 and positive 1/4. My axis of symmetry is the equation of x equals 3 over 2. My y-intercept, I'm going to take it from the original equation because I know the c value when it's in that quadratic form. The c value is the y-intercept. So it's going to be as an ordered pair, 0, -2. And the only thing left to figure out here is what is the x-intercept. So to find the x-intercept, I can use the original equation or I can use the vertex form. Either way, I have to make the y value equal to 0 to find that. So I'll use the vertex form. So I'm going to set the equation equal to 0, -1 x minus 3/2 squared plus 1/4. And I'm going to start by subtracting 1/4 from both sides. So I have that. Then I can multiply both sides by -1. So I can get rid of this -1 here. So I'm going to end up with positive 1/4 equals x minus 3/2 squared. I'm going to now take the positive and negative square root. So I'm going to get plus minus 1/2 equals x minus 3 over 2. And then I'll add 3 over 2 to both sides. So let me clean this up a little bit. I can think of this as 3 plus or minus 1 over 2 equals x. And I know that that equals 3 plus 1 over 2, which is 4 over 2, which is 2. Or 3 minus 1 over 2, which is 2 over 2, which is 1. So I know that my x-intercepts are 2 and 1. So my x-intercepts are going to be 2, 0, and 1, 0. And so those are all the answers there that they're looking for. The next one says find the vertex, axis of symmetry, x and y intercept, and actually graph it. So again, this one's a little bit different because this one is in a different form. It's already in vertex form, so it made it a little bit easier. The vertex, I can identify really quickly. It's going to be -3, -4. The axis of symmetry is going to be the line of x equals -3. My x-intercept, I have to make the entire equation equal to 0. So let's do that. X plus 3 squared minus 4. I'll add 4 to both sides. Then I will take the plus minus square root. So I'll get plus minus 2 equals x plus 3. And then I'll subtract 3 from both sides. So I have x equals -3 plus or minus 2. And I know that's -3 plus 2 is -1. And -3 minus 2 is -5. So that means my x-intercepts are located at -1, 0 and -5, 0. Like that. And my y-intercept, I have to make x equal to 0. So I make x equal to 0, and I figure out what y is. So that's going to be 3 squared minus 4, 9 minus 4 equals 5. So I know my y-intercept. If x is 0, y is 5. And last but not least, I have to graph. So if I'm going to graph this, the graph that we would expect is we would expect to see the vertex 1, 2, 3, 1, 2, 3, 4. So the vertex is here at -3, -4. So my axis of symmetry runs through that. So there's the line of x equals negative 3. My y-intercepts are negative 1, 0 here, and then negative 5, 0 here. And my y-intercept is 0, 5. So I know that my graph looks like this on the left, and I know that I should mirror it if it's if I go 3 units to the right and I'm at 5, then if I go 3 units to the left, I should also be at 5, and so I should mirror that. And so those values should all be there. So you should have your vertex, your 2 x-intercepts, you should have your y-intercept on your graph, you should have your axis of symmetry, and you should have some mirrored value on the left side. Number 4 is the same concept. It's in a quadratic form, but let's do this one because in this problem, what we would do, it's not asking you to convert to vertex form. So what you can do is you can use the formula for your vertex. You're going to do x equals negative b over 2a. So in this problem, a is 3, b is negative 5, and c is negative 4. So you're going to do the opposite of negative 5 over 2 times a, which is 3. So it's going to be 5 over 6. So the x value of my vertex is going to be 5/6. The y value of the vertex, well, I've got to take the original equation and I've got to plug 5/6 in for x everywhere where I see an x, which is a little bit of a pain because it's a fraction. So I come over to here, 5/6 squared is 25 over 36. 5 times 5/6 is 25 over 6 minus 4. I know this simplifies to 25 over 12. This would be 50 over 12 if I rewrite it. And this is minus 48 over 12. Okay, equivalent fractions are super important if you can do them. So 25 minus 50 is negative 25. Negative 25 minus 48 is negative 73 over 12. And so negative 73 twelfths is the y value of your vertex. So now you have your vertex, your axis of symmetry is going to be the line of x equals 5/6. Your x-intercept, again, it's going to be the same idea. You set the whole equation equal to 0. Your y-intercept in this form is easy because, again, it's the c value. So it's going to be 0, negative 4. And then we're going to graph it. So I need to find the x-intercept. So I'm going to set the equation equal to 0. So 3x squared minus 5x minus 4. I'm going to try first to see if I can factor this. I've got minus 12 is the product, minus 5 is the sum. What multiplies to negative 12 and adds up to negative 5? And I can't think of anything. So it isn't something that I can solve that way. So I'm going to have to do the I could complete the square or do quadratic formula. I'm going to choose quadratic formula. So I'm going to do x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we keep doing the math here. We get positive 5, and this is going to be 25 plus 48 all over 6. And it's 5 plus or minus the square root of 73 over 6. And so once I've got that, then I know that's the x value. So my x-intercept is going to be 5 plus or minus square root of 73 over 6, comma 0, because I write it as an ordered pair. And then last but not least, we have to graph this. So let me just kind of move this up. So if I go to graph this, I know that, again, my vertex is 5/6, negative 73 over 12. So obviously I'm going to make my thing a little bit bigger, right? And I know that I'm going to make my 73 over 12 similar, is close to somewhere between 6 and 7. So I'll make the y-axis a little smaller. Okay, so if this is -6 and this is -7, then I know, let's say 5, 6 is about there, and it'll be around here. Okay, so again, not great numbers, not great to work with. Try to do some kind of let us know what your scale is in your interval, but it should be about there. I know that my y-intercept is at -4, so my axis of symmetry goes through here. Okay, so this is the line of x equals 5, 6. And I know that if I go 5, 6 units to the left, I'm at -4. So I know that if I go 5, 6 units to the right of that, maybe about here, I'm going to be at about the same place. Now, my x-intercepts, again, are going to be a little bit difficult as well. The square root of 73 is about, between 8 and 9, so it's about 8.5. So 13.5 divided by 6 is going to be something around 2. It's not going to be great, but it's going to be around here. And if I subtract that, 5 minus 8.5 is about 3.5. It's going to be about a half, or -1/2. So it's going to be somewhere around there. When your x-intercepts are these weird numbers, it's going to be hard to be accurate. If you can just kind of get an idea of what big numbers it's between, that would be enough. But most importantly, in this kind of equation, you definitely want to show us the vertex, the y-intercept, a mirrored point over to the right, and then try to get as close as you can to the x-intercepts. Also, you always want to show us your axis of symmetry. Okay, so here again, we have a similar kind of problem. We've already done a few of these. I think we're good with this type. Here, they're asking us to graph by finding the x-intercepts, y-intercepts, and behavior, and a few additional points. Now, we have not really talked much about these types of problems, and we did not really talk much about end behavior. It's not going to be on this particular tests. Okay, so I think this one, we'll leave out because we're not going to give you any real questions like this. Obviously, your x-intercepts are your solutions. So, if you're thinking about it, I'm going to want set it equal to 0, right? So this is x minus 3, x minus 3, x plus 2, and x plus 4. So I know that my solutions are going to be x equals 3, and it's repeated. It has multiplicity. We've got x equals -2, and x equals 3. So my x-intercepts, I know, are going to be 3, 0, -2, 0, and 3, 0. Oh, I don't know what I was thinking over here. Sorry, guys, this is -4. I don't know where that came from. And so it's going to be -4, 0. Okay, so those are my intercepts, and yes, my x-intercepts, and yes, there's multiplicity. For now, I think I would leave it at that. I could set it, I could make all the x's, I could find my y-intercepts by setting all my x's equal to 0. So y minus 3 squared, or 0 minus 3 squared, 0 plus 2, 0 plus 4. So this is going to be -3 squared times 2 times 4. This is 9 times 2 times 4, 72. So my y-intercept is 0, 72. So I can get the x-intercepts, I can get my y-intercepts, I can get some extra points, but the end behavior is the one that we haven't really gotten to. We'll get to that one soon when we move on to the next section, but it's not going to be on this assessment. And lastly, it says graph by finding the x-intercepts, y-intercepts, again, and behavior we're not going to worry about, and a few additional points. Now, this is a 4-term polynomial. You might think of trying to group it. It's not groupable. I can't find my x-intercepts until I can factor and solve this, so I've got to figure out how to factor this. I'm going to have to find some possible zeros, and I'm going to have to use synthetic division to get there. So my possibles, again, my factors of the first coefficient are 1, my factors of the last one are 1, 2, 3, 4, 6, and 12. So I know my possibles are plus minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. So since it's over 1, it's easy, and they're all plus minus. So I come over to here and I have to start chipping away, right? So I've got a 1x cubed, a minus 10x squared, a plus 21. Well, I don't really need to write the plus. I have a 21, and I have a 12. I don't have any missing exponents, so I don't have to put any placeholders. And I'll just start by starting with 1 and seeing if it works. So I multiply, I get minus 9, that gives me 12. Right? Minus 9, that gives me positive 12, and that's 12, and that's 24. So that doesn't work. So let's try negative 1. So I've got minus 1, minus 11, that's positive 11, so that's 10, minus 10, so that's 2. So that doesn't work either. So that doesn't work. So we have to kind of chip away. I'm not going to do the video of trial and error for all of them. I'm going to jump ahead. I know that 4, I believe, works. So I'm going to just jump over to 4. But you would try positive and negative 2, positive and negative 3. And you get to 4 here, and you end up getting minus 6, minus 24, minus 3, minus 12, and 0. And we finally get one that works. So I know that one of my factors, if I break this down by factors, I know it's going to be x minus 4. If I break it down by solutions, I know my first solution is 4. What's left over, I'm going to create a new polynomial with it. Since I started with x to the third, it's going to be 1 less than that. So it's going to be 1x to the second minus 6x minus 3. Now at this point, if I could factor this, I would. Now, unfortunately, it's not factorable, so I have to use the quadratic with that. So I know I have an a of 1, a b of minus 6, and a c of negative 3. So x equals the opposite of b plus minus b squared minus 4 times a times c all over 2 times a. So what does that become? That's 6 plus or minus, and that's 36 plus 12, so that's 48. And then I get 2, and I can simplify this a little bit. 6 plus or minus 4 radical 3 all over 2, and when I simplify that, it's 3 plus or minus 2 radical 3. Okay, so that's what my x is equal. So my other two solutions are 3 plus or minus 2 radical 3. Notice I got 3 solutions total. It's a cubic function. I should expect that. My intercepts are going to be then, let's kind of get here. So my x-intercepts are going to be these values right here. Going to be 4, 0, and 3 plus or minus 2 radical 3, 0. My y-intercepts, my y-intercept, as always, is going to be the value of the function, value of y when x is 0. If I come through here, if I go to this original equation and I make this one 0 and this one 0 and this one 0, y is just going to equal 12. It's always that constant. So my y-intercept is 0, 12. And the end behavior, again, we'll talk about. We're going to get to that in the next section. And it says graph a few additional points. So we could go ahead and we could do that. But in reality, we're not going to ask you to graph an x to the third or anything like that because we haven't gotten to that yet. That comes with end behavior. So you don't have to worry about that either or the graphing for this assessment. You're just going to be finding your factors, using those factors to find your solutions, which are your x-intercepts, and then you make x is equal to 0 and find your y-intercept. And that's it. All right, so then we go here, write an equation of a parabola in standard form. Again, the equation, we know we've got y equals a times x minus h squared plus k. And so if they gave us the vertex, what they're giving us is the h and the k. And if they're giving us a point, they're giving us the x and y. So we're going to use those points. We're going to plug the y that they gave us in. We're going to plug the x that they gave us in. We're going to plug the h, which is the 3. And we're going to plug the k, which is the 2. And if you notice, the only variable we have left is the a. And so that's what we're going to solve for. So 5 minus 3 is 2 squared plus 2. Negative 6 equals 4a plus 2. So negative 6 equals 4a plus 2. We're going to subtract 2 from both sides. Negative 8 equals 4a. And if I divide both sides by 4, I'm going to get that a equals negative 2. So now what I do is I go back to the original equation, the y equals a times x minus h squared plus k. I'm going to leave the y. I'm going to put the negative 2 in for the a, and I'm going to leave the x in there too. I want the x and I want the y. The a, the h, and the k get replaced. So the a is negative 2. We already know that the h would be a minus 3 here, and the k is a plus 2. And so here we have the equation of that parabola that has a vertex of 3, 2, and goes through the point 5, negative 6. For number 12, they want you to do the same thing. They give you the h, they give you the k, but it tells you it runs through the y-axis at 1. In other words, the y-intercept is 1, which means it goes through the point 0, 1. So now you have your x and your y, okay? And then last but not least, we get to number 13. It's going to ask you to use the remainder theorem to find the value of the function when x is negative 2. So what you're going to do is you're going to start by putting it in standard form. So you've got minus x to the 4th plus x squared plus 3x minus 2. So you're going to put it in order, and then you realize that there's a value missing. You need to add a placeholder because you don't have an x cubed. So 0x cubed plus 1x squared plus 3x minus 2. Now that you have it in the correct form, now you can put it and prepare your synthetic division. So minus 1 is your first coefficient, 0 is the second, 1 is the third, 3 is the fourth, and minus 2. And what you're going to do is you're going to plug negative 2 in and solve for it. Whatever the remainder theorem says, that whatever the remainder is the value of the function when x is negative 2. So I'll bring down the negative 1, we'll multiply, and then we'll add. We'll multiply, and we'll add. We'll multiply again, and we'll add. We'll multiply, and we will add. And here's the end. My remainder is negative 20. And what that means is the value of my function when x is negative 2 is negative 20. Now you can check it. You know, you might want to go in there and check it. You might say, okay, let's take the original equation, x squared minus x to the 4th plus 3x minus 2. So you're going to do minus 2 squared minus minus 2 to the 4th plus 3 times minus 2 minus 2. 4 minus 16, or minus 6 minus 2. I'm going to get minus 12 minus 6 minus 2, minus 12 minus 18 minus 20. And notice we got the same answer. This is much longer, okay? Use it to check, okay? Obviously, you know, if you don't have time, don't check it, but we do want you to use the remainder theorem, which means you're going to have to use synthetic division to solve it. We don't want you doing this, okay? This is only to check. That's the only reason I would do it. And then again, number 14 is the same kind of problem. So hopefully Now you have an idea of how to solve all these problems.